this video, we are going to be looking at the area of a triangle, but we're going to be doing so in a new way. So I'm hoping that by this point you are already familiar with the original formula for the area of a triangle, which is just the base times the perpendicular height divided by 2. Now we've got lots of ways of writing this. This is just one that I've chosen, but they're all following this same idea. We have to find one length, which we call the base, then we find the perpendicular height of the triangle, and then we divide by 2. Now this rule is fine, but it does involve us finding the perpendicular height, which is not always particularly easy to do. So it'd be nice if we had a formula that didn't involve the perpendicular height, and indeed we do. Area is also half times AB sine C. So half AB sine C. Now in my next video I'm going to show you where this formula comes from, but in this video I'm just going to use it, and you're just going to have to believe me for now. So what do these letters mean, these A, B and C? Well, this is another way of labelling a triangle which is going to be useful in the next few videos. Here I've labelled my triangle with the letters A, B, C, capital letters and little letters A, B, C. And I've followed the following two rules. I have used capital letters for the angles, so this is capital A, capital B, capital C, and I've used the little non-capital letters for the side lengths, so this is A, this is B, and this is C. You'll also notice that the letter pairs are opposite each other, so here A and A are opposite, C and C are opposite, B and B are opposite. Now it's important that you label this correctly. So in theory it doesn't necessarily matter which order we put the A, B and C in the middle or on the edges, as long as we make sure that these rules are followed, so we make sure that the pairs are opposite each other. Otherwise the calculations stop working. And this is going to be important for a few different formulae, not just for the one today. So make sure you get this right. Now you'll also notice, because this doesn't really matter, our version of writing the area, half AB sine C, is not the only way to write this formula. It would be exactly the same to say that the area is half BC sine A or half AC sine B. These three are all the same formula because it doesn't matter. But we tend to prefer this one only because it's in alphabetical order, A, B, C. So if you decided you wanted to be rebellious and start using BC sine A, that would be fine. But we do tend to hear of this one instead. Right, so how am I going to use this formula? We now have a formula, how am I going to use it? Well, we're going to start with a triangle like this. And this is generally what you're looking for this formula to work. You're looking for an angle in between two lines that you know the length of. So I don't need to know this angle or this side. But if I've got the two lines that touch each other, the two sides that touch each other, and I know the angle between them, then I can use that to find the area. So my area formula is, as I said, half AB sine C. So I need to look at, well, which bits of information do I need here? I need to know an angle C. So it makes sense to call this angle here angle C, because that's the one I need to know for my formula. So I'm going to call that angle C. And that tells me that this length here has to be C, because they have to be opposite each other. So if this is angle big C, this has to be side length little c. I also need A and B as side lengths. Now it doesn't actually matter which order I put them in, doesn't matter. But what does matter is that I then put the angles in correctly after that. So if this is little a, that needs to be big A. If that's little b, that needs to be big B. So here I've got a fully labelled triangle. And from this point on, it's just plugging in the numbers. So the area is half AB sine C. A is 3, B is 5, and C is 43. So I put that into my formula. Now notice that this has to be a capital C. That's something that people do get wrong sometimes. We know this has to be a capital C because it has to be an angle that we're sining. If we're finding sine of something, then it's supposed to be an angle, isn't it? That's how this works. So that needs to be the sine of 43 there. And then I'm going to type that into a calculator. And apparently the area of the triangle is 5.11 centimeters squared. And that feels like it makes sense. It feels about the right size. It's a good idea after you've done this to have a quick check. Does the answer feel like it makes sense? And this one feels pretty much all right. And the other thing that's worth thinking about is the units. So I've had to use here centimeters squared because I know that this is an area calculation. So it needs to be square units. Right, here's another one. So now the angle's in a different place, but that's not going to throw us off. I still have this two side lengths connected to each other and the angle between them. So the area is half AB sine C. I'm going to have to call this angle is the one I know, so it's going to have to be C, which means that the side opposite is also C. It doesn't matter which way around I get A and B, so I'm just going to put them in randomly, and then make sure I get the angles opposite correct. So this is little a, so that needs to be big A. That's little b, so that needs to be big B. And then I'm going to plug in my numbers. So A is 21, B is 11, and C is 17. If I plug that into a calculator, I get 33.77 centimeters squared, which again to me feels approximately correct for the area. Next one. We have got an angle and two sides connecting each other, so we should be able to find the area here. The area is half AB sine C. I'm going to need to label the angle as C, because that's the angle I need, which means the side opposite needs to be C. I'm going to label these as A and B, doesn't matter which way around, and then make sure the angles are correct based on those. And then I'm going to plug in my numbers. A is 1.1, B is 2.2, and C is 51. And I'm going to shove that into a calculator. 0.94 kilometers squared. Okay, one final example, just to make sure we can nail this. So the area is half AB sine C. I've been given this angle, which is C, which means the side opposite is C. Now notice that we don't actually need this side. I'm telling you it's 5 centimeters. You don't need to know that. It's irrelevant information. So don't get thrown off by the fact that sometimes a question will have irrelevant information. It'll have things in there that you don't actually need to know. It doesn't matter which way around these two are, as long as they're A and B. So I'm just going to call them A and B. And then make sure the angles opposite are correct. So capital A has got to be opposite to little a, and capital B has got to be opposite to little b. Plug in the numbers. So A is 4, B is 3, and C is 90. So we've got half times 4 times 3 times sine 90, which if I plug into my calculator gives me 6 centimeters squared. Now this one actually shouldn't surprise me at all, for two reasons. Firstly, because I've got sine 90 here, and we already know what sine 90 is. It's one of our exact values. So we know that that's 1. We know that sine 90 is 1. That's useful to know. But also, I mean, if this is 90, then that would make this a right-angled triangle. And we know the right-angled triangles are easy because it is just base times perpendicular height. So it would just be 3 times 4 divided by 2, which is 6. So that answer shouldn't be surprising. This was actually an easy question. If anything, we were overkill by using this formula, but it's nice to know that the formula still works in these cases. Okay, the key points from this video. So the area of any triangle can be found with the formula half AB sine C. And it is important to note that this is any triangle, not just right angle triangles, not just some special triangle. This formula will work for any triangle as long as you know the right bits of information about it. We use capital letters for the angles and non-capitals for the side lengths. And we make sure that we label them in pairs. So we label the opposite angles and sides with the same letter.